Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of quadratic equations. And if I talk about the question which is given to us here, the question tells us that we need to find out how many real roots are present for the quadratic equation which is given to us, that is x into mod of x minus 5 times mod of x plus 2 plus 6 equal to 0. And there are four options given to us for the number of real roots in the question, that is 3, 4, 5, 6. So we need to figure out which one of the following options is the correct answer for the number of real roots for this quadratic given to us. Let's try to solve this and find the value of the expression or the number of real roots that this equation can have. So before starting with the question, first let's understand the concept. So if I talk about the concept that we are following here, we know that if x is positive, mod of x is asked to me. So for example, if I have mod of 5, I write it as it is. Because mod of anything positive or negative always gives you a positive value. So if the expression inside the mod is positive, you write it as it is. The second idea we have here is if the expression which is present inside the mod, if it is negative, for example, if I have minus 5's mod to be found out, that also gives you a positive answer 5. Now, how do we get that? Basically, we get that because whenever an expression inside the mod is negative, you multiply that with -1. So if I have x within the mod negative, I'll multiply that with -1. That gives me answer which is positive. That makes it -x. Now don't get confused with this idea that we said mod of anything always gives you a positive value, then why we are getting -x here. Understand that -x basically denotes minus, and x which is present is also negative. So minus of negative value makes it totally positive. So that's why you're getting a positive answer only here. You're just seeing that minus sign, so you feel that it is negative, but it's not negative. The answer actually becomes positive. So the concept that we are going to follow here is if an expression inside the mod is positive, you write it as it is. If the expression inside the mod is negative, you multiply that with -1. So let's see the idea now. If I have that quadratic equation given to me, that is x into mod of x minus 5 times mod of x plus 2 plus 6 is equal to 0. Now what we'll do is whenever you have to solve this type of equations with absolute values, the expressions which are inside the mod just equate them with 0. So if I see the first expression inside the mod, I get the value of x equal to 0. The second expression inside the mod, I again equate with 0, I get x as -2. So once you get two values or three values or whatever values of x are there, just plot them on the number line. So if I plot them on the number line, I have 0, I have -2. So I have these two values plotted here. Now those two values basically divide your entire number line into three regions. So one region you have here is x less than -2. The other region you have here is x less than 0, greater than or equal to -2. The third region you have here is x greater than or equal to 0. So let's just analyze this idea. So if we see here, in the first region, if I try to analyze my equation, if I write that equation again, and if I analyze it in the first region, so first region, if I analyze it in where x is less than -2. So if I take any value of x, let's say -5, this expression inside the mod is negative because it's -5. -5 plus 2, it's also -3, which is also negative. Since both of the ideas are negative inside the mod, what we do is whenever something inside the mod is negative, we use the second idea that we multiply that expression with -1. So if I multiply this expression with minus 1 entirely, x into mod of x becomes multiplied and becomes minus x minus 5. This entire expression also gets multiplied with minus 1 plus 6 equal to 0. From this you get an equation minus x square minus minus, so plus 5 x plus 2 plus 6 equal to 0. If I take them all on the other side, it becomes x square minus 5 x plus 2 plus 6 equal to 0. So you get this x square minus 5x. Instead of plus 6, it becomes minus 6 also. So minus 10x, sorry, minus 10 minus 6. So you get that entire expression turning out x square minus 5x minus 16 is equal to 0. So you have this quadratic equation with you. Let's just solve this by using the formula. We know by formula method that x can be found out by minus b plus minus root of b square minus 4ac upon 2a. So if I compare this with general equation ax square plus bx plus c equal to 0, I get a1 b minus 5 and c minus 16. a1 b minus 5 c minus 16. If I put that in the values and find x here, let's do that. So plus 5, because minus of minus 5, plus minus b squared, so 25 minus 4, a and c, so 4, a into c is minus 16 upon 2 into a here is 1. You get 5 plus minus 25 plus 64, which is 89 upon 2. So 5 plus root 89 by 2, and you get 5 minus root 89. Now when I see this, root 89 will be somewhere close to or somewhere between 9 and 10. So 5 plus, if I even do 9.5, let's say 14.5 upon 2, this gives you a positive value. This becomes 5 minus 9.5. If I do, it becomes somewhere minus 2.5 or minus 4.5 divided by 2. That gives you approximately equal to minus 2.2. Now I get two values of x, and I know that the first region was when x is less than minus 2. So x cannot be positive here. So x equal to a positive value is rejected, because that does not even lie in the first region where we are analyzing. X is less than minus 2. So this region x equal to minus 2.25 is satisfying this expression. So we have got one real root from the first region. So from the first region we have one real root. So out of the two roots we got, one is satisfying that, the other is not satisfying, so it is rejected. Now let's analyze the same quadratic equation in the other region, where x is less than 0 but greater than or equal to minus 2. Now when it is greater than or equal to minus 2 here, this expression turns out positive, because if I put, let's say, minus 1 plus 2, this becomes plus, but this still remains negative. So the first expression, since it remains negative, you get expression inside the mod is negative, you multiply that with minus 1. So you get the quadratic as x into minus x, because it was negative, minus 5. The second expression, since it is positive, you write it as it is. So x plus 2 plus 6 equal to 0. If I again solve this, you get minus x square minus 5x minus 10 plus 6. So minus x square minus 5x minus 10 and plus 6 becomes minus 4 equal to 0. That gives you x square plus 5x plus 4 equal to 0. If I try to solve this again, I can just solve it by just splitting the middle term. We don't even need to apply the formula here. So I can just split, because 5x I can write as 4x plus 1x. So that gives you x square plus 4x plus 1x plus x common. We get here x equal to minus 1 or x equal to minus 1. So we get again two values of x. Now if I see our region was between x 0 and -2. So when it is between 0 and -2, only x equal to -1 is going to satisfy. -4 is beyond this region, so it does not satisfy in this region. So this value is again rejected, and we get one answer from this region as well. So from this also we get one real root which is satisfying the expression, the quadratic equation given to us in terms of absolute values. Now let's just see the third equation, the third region which we get here. It is when x is positive or equal to 0. So for that third region, we know if I put any value of positive, let's say 1 also here, 1 plus 2, 3, 1 is again positive. Both the expressions inside the mod are positive. So when they are positive, we write them as it is. So I'm just using this idea in the two expressions that we have been given. So if I write that x into x minus 5 into x plus 2 plus 6 equal to 0. So we are just writing the two expressions as it is. So you get x square minus 5x minus 10 plus 6 equal to 0. Get x square minus 5x minus 4 equal to 0. Now minus 4 I cannot split the middle term again. So again I'll have to do the formula method. A is 1, A is minus 5, C is minus 4. So x becomes minus b, so minus of minus b plus 5 plus minus square root of b square, so 25 minus 4 ac upon 2, get x equal to 5 plus minus root of 25 plus 16, which is 41 upon 2. So we know 36 and 49, it lies between them. So you get x equal to 5 plus minus somewhere close to between 36 and 49, let's say equivalent to, let's say 6.5. Not exactly equal, but equivalent to that. So when I take equivalent to 5 plus 6.5, 13.5 divided by 2, that's a positive value. 5 minus 6.5 minus 1.5 divided by 2, that's definitely negative. So I get x equal to a positive, equivalent to a positive or a negative value. So two answers again. One is positive, other is negative, but our region tells us that x is greater than or equal to 0. When it is greater than or equal to 0, only the positive values of the root satisfy this. So this is a correct answer, but this is going to be rejected. So from the third region also we get one real root that satisfies the quadratic equation. So when we are done analyzing all the three regions, we have completely analyzed the entire number line, and from every region we got two roots, but in every region one roots were rejected because they do not lie in those regions. They gave us an inconsistent solution. So from every region we got one real root. Total number of real roots we had in the entire question was three real roots are present for the quadratic equation given to us. So the number of real roots, the correct answer for that question comes out to the conclusion. I hope you have understood this method of critical key points to solve this idea of quadratic equations using the concept of absolute values. So we use this idea of concept that if something is positive inside the mod, you write it as it is. If something is negative inside the mod, you multiply that entire expression with. And then we solved our entire question using critical key points. So whatever expressions are inside the mod, equate them with 0. That will give you two values of x. So from these two values of x, once we plotted them on the number line, we got three regions. We analyzed all the three regions. We used that concept again. And once we analyzed, we got 6 roots, out of which 3 were rejected. So 3 real roots satisfied that entire quadratic equation which was given to us. So from that we got the answer that number of real roots for this quadratic equation is option A, that is 3. I'll see you again tomorrow with some other question from some other topic, and we are going to continue our series of questions on JEE Mains as well as 11th and 12th. So stay tuned for more videos to roll out. Do like, share and subscribe to my channel. Do share these videos with your friends also who are involved in this participation of JEE questions. Thank you.